There is nothing more important to a driver than the ability to control their vehicle under all driving conditions. Whether turning, braking, or going straight down a bumpy road, steering and suspension systems give the driver the confidence that their truck will handle in a safe, predictable manner. The ASE T5 steering and suspension test will cover all of the systems that are used to make the truck handle properly. In this video, we'll look at the tasks covered in the T5 tests and the diagnostic tests that you can use when faced with a steering or suspension problem. Since we won't be able to cover all of the task areas in this video, be sure to make notes and use the excellent textbooks, test preparation guides, and service manuals to do further study as you get ready to take the T5 test. Steering system diagnosis and repair includes diagnosis of the steering column, power steering systems, and front steering bushing and steering linkage systems. Diagnosis of any steering or suspension problem begins by getting the best information possible from the customer and then driving the vehicle if necessary to verify the condition. For concerns about looseness, binding, or noise in a steering column, start with an inspection of the front steering bushing. A worn bushing will leave a gap in the linkage that can cause a loose feeling when driving straight, or a noise over bumps, or a pull to one side as the vehicle drifts on the crown of the highway. If the front steering bushing is okay, check the column to cab mounts and the U-joints in the steering column. Push against the joints with your hands to test for looseness, and never use force that could damage the tension spring in the joint. If the concern for looseness or binding is not in the steering column, then check the linkage, kingpins, and kingpin bearings and caster before condemning the steering gear. This is particularly true if the concern is for a steering wheel that is off-center or does not return to center after a turn. Worn steering gears will cause problems with turning effort, binding, looseness, hard steering, leaks, and overheating of the power steering fluid. Always check the adjustment of the gear when troubleshooting concerns of loose or binding steering. Beyond that adjustment, the gear will have to be removed and disassembled for further diagnosis. If you suspect the problem is hydraulic rather than mechanical, check the power steering fluid. Low levels of fluid will cause increased steering effort and erratic steering, as well as a noise from the pump. Aerated fluid is an indication of air in the system or a low fluid level that can cause erratic steering effort. Follow the bleeding procedures to purge the air once the fluid is up to operating temperature. If the fluid level and condition is okay, inspect the belt adjustment and the pulley from the power steering pump. There's no check for gear-driven pumps other than mounting. And don't overlook the mounting brackets and bolts that can come loose from vibration for both gear-driven or belt-driven steering pumps. Testing the hydraulic pressures in the power steering system requires the use of a power steering analyzer between the high-pressure hose and the steering gear. Always exercise extreme caution when working around power steering systems because the fluid pressure can exceed 2,500 psi and the fluid temperature can reach 180 degrees. The test procedures will show problems with restrictions in the high pressure or return lines and pinpoint a worn pump or stuck control valve or troubleshoot internal steering gear leakage requiring repair. The power steering pump will have to be removed and disassembled or replaced if the test shows low PSI and low flow indicating a defective pump. High PSI and flow indicates a properly working pump. Normal PSI, but more than 1 gallon per minute internal leakage, indicates steering gear problems. Complaints of looseness in the steering, a steering wheel off-center, a low-speed shimmy, interference noises on turns or over bumps, or hard steering can all be related to the steering linkage. When dealing with these concerns, check for excessive wear in the pitman arm, drag links or relay rods, tie rods, idler arm assembly, or the steering arm and levers. You can test each of these parts by looking for signs of wear or damage and by pushing against them with your hand to check for excessive movement. Never pry on the linkage or use excessive force when testing them, as good components can be damaged. Any worn linkage, bushing, or bearing will require replacement and a check of the alignment after replacement. Make sure all lock mechanisms are properly reinstalled. Many truck front suspensions are solid I-beam axles sprung on multi-leaf springs. The axle is connected to the steering knuckle by kingpins. Problems with bent or twisted I-beams may not be visible to the eye. Measuring front wheel setback will give you an accurate indication of how true the I-beam is. A machinist's protractor can be used to determine if the axle is twisted. Bent or twisted I-beams will result in alignment angles that are off and can cause accelerated tire wear or poor handling. Kingpins, or knuckle pins as they are also called, provide the pivot points for turning the front wheels. Worn or loose kingpins or kingpin bearings can cause a shimmy or vibration while driving. Under-lubricated kingpins can cause the steering to bind. Kingpins are tested with a dial indicator to check the vertical play in the kingpin as the knuckle is pried down. Any kingpin with excessive play must be replaced. When lubricating the kingpin bearings, make sure to continue greasing until some grease comes through the pilot bearing to ensure a thorough distribution of lubricant. I-beam kingpin lubrication is a two-step process. Lube with the truck on the floor, loaded axle, and again unloaded, truck off the floor. Along with providing the pivot points for turning, the front suspension must also keep the wheels on the road to ensure safe operation during steering, riding, and braking. This is the main function of the shock absorbers. Worn shock absorbers will result in excessive jouncing and rebound over bumps that can cause the front end to bounce and the steering wheel to oscillate, and often a loss of directional stability as the spring oscillations are uncontrolled. Disconnecting one end and checking for bent pistons or worn bushings is one way to test shock absorbers. Also check for oil leaking at shock seals and cracked or damaged dust seals. Use care when disconnecting gas shocks, as the pressure will force the piston outward once the shock is disconnected. Shock absorbers should be replaced in pairs. Leaf springs are used to lower the center of gravity of the axle load by placing the I-beam below the axle center line. Problems with springs are usually noise-related or can affect handling by causing the vehicle to sway. Broken springs or cracked leaves will cause uneven vehicle height side to side. Start your diagnosis of suspected spring problems with a visual inspection of the spring leaf, mounts, center pin, bushings, shackles, and U-bolts. If you find a broken leaf spring center bolt, suspect loose front spring U-bolts. A broken center bolt can cause premature tire wear or vehicle dog tracking that can be confused with the type of wear from improper toe-in adjustments. Air spring suspensions provide a smooth, vibration-free ride and automatically adjust ride height. They use air from an air reservoir through single or dual height control valves to maintain a constant ride height. Air leaks in the system are easily diagnosed by soaking the fittings on the valves and springs with a leak detector solution and looking for air bubbles. Before loosening any air suspension lines or fittings, release all the air pressure from the air brake reservoirs and system. Failed air springs will result in a low ride height. If the vehicle height is too high, suspect a misadjusted height control valve. A vehicle that sits too high or too low may have a misadjusted ride height control valve. The valve uses a control rod located between the control valve and the rear axle to gauge ride height. Height control valves must be adjusted with the vehicle unladen, the air springs deflated, and the frame supported on suitable jack stands, or following the recommended manufacturer's procedures. Air suspension rear axles, where adjustable, are adjusted with an eccentric pivot bolt on the front beam bracket. The diagnosis of handling concerns related to vehicle alignment starts with the basics. Always check the tire pressures and wheel lug nut torque before road testing the vehicle. Look for loose lug nuts or rust around the lug nuts. Low tire inflation will cause problems with hard steering effort, tire wear, and can cause tire overheating and possible tread separation. Concerns about rough ride can be related to worn shock absorbers, loose or worn suspension components, improper wheel balance or lug nut torque or bent wheels, or improperly adjusted wheel bearings, all of which may show up as tire wear, so be thorough in your inspection. If the tire pressure and suspension components are okay, road test the vehicle to verify the complaint. Camber is the inward or outward tilt of the top of the tires from the vehicle's center line. Camber is a tire wear angle that will cause tread feathering or wear the inside or outside edge of the tire, depending on whether there is excess negative or positive camber. Camber is checked on an alignment machine. Camber is not adjustable on I-beam axles, so the cause of unacceptable camber must be determined. If you have already checked the suspension components and found them to be okay, excessive tire wear may be caused by the I-beam being bent or twisted. Follow the manufacturer's procedures to straighten the I-beam if that is an acceptable procedure. Kingpin inclination, or KPI, is the theoretical line through the center of the kingpins in relation to true vertical when viewed from the front. The included angle is the sum of the KPI angle and the camber angle. KPI helps to return the wheels to a straight-ahead position after a turn. The higher the KPI, the higher the steering effort. KPI should always be checked for concerns about hard steering or poor steering wheel return, as well as for concerns with directional stability. KPI, like camber, is not adjustable and will require further inspection of the axle and the kingpins if excessive tire wear is present. Caster is not a tire wear angle, but affects vehicle steering and directional stability. Caster is the tilt of the vertical line through the center of the kingpins in relation to the true vertical center line of the tire and wheel when viewed from the side. Excessive positive caster increases steering effort and creates a very rapid steering wheel return to the straight-ahead position. Excessive positive caster can also cause a wheel shimmy at speed. Excessive negative caster reduces steering effort and decreases vehicle directional stability. If the complaint is a vehicle that wanders down the road, suspect excessive negative caster. Caster is adjustable by inserting the correct size shim between the front springs and the I-beam axle. Make sure the shim is installed in the right direction and use only one shim of the right size and not combinations of several thinner shims to adjust caster. Toe is a measurement of the distance between the inside front of the tire and the center line of the vehicle compared to the distance of the inside rear of the tire to that same center line. Where the front of the tires are closer to the center line than the rear, the tires are toed in. Where the rear of the front tire is closer to the center line than the front, the tires are towed out. Tow is usually checked using a trammel gauge with the front suspension in a neutral position or relaxed state. Tow is a tire wear angle. Tire wear from improper tow will have a feathered appearance on the tread edges. Excessive tow in will wear the outer edges of the tread, while excessive tow out will wear the inside edges. If camber and caster are correct, concerns about a vehicle pulling to one side are usually related to excessive tow-in on the side opposite the direction of the pull. Pulling can also be caused by excessive wheel setback on the side that the vehicle is pulling towards. This might be caused by a loose U-bolt mounting or a bent I-beam axle. Similar to a front-end pull is the push created by an improper rear thrust angle. If the rear tires are not aligned with the front axle, they will push the vehicle to one side. If tandem axles are of unequal wheelbases between front and rear axles, the vehicle will push to the side with a shorter wheelbase. Worn equalizing beam bushings or bent torque rods and loose axle U-bolts can cause incorrect rear alignment. Inspect all components before performing a rear wheel alignment. If the components are okay, the alignment can usually be brought into specification by either shimming the torque rods or using the eccentric pivot bolts on the equalizer beams. Perhaps no one area in truck repair poses as great a safety concern, both to the vehicle operator and to the technician, as wheels and tires. That's why it is essential to follow all safety precautions and exercise extreme caution when working around tires and wheel rims. Common concerns with tires fall into two categories: vibration and tire wear. Vibrations at speed can be caused by improper wheel balance, bent or out of round wheels, improper wheel lug torque, loose wheel bearings, worn suspension components, or separated tire treads. Start your diagnosis of vibration problems with a check of these basics. If you are unable to bring a wheel into balance using a static or dynamic wheel balancer, check the wheel and tire runout. Wheels and tires with excessive runout must be replaced or remounted. Improper inflation, improper alignment, or worn suspension components usually cause tire wear. When diagnosing tire wear patterns, refer to the readily available tire wear guides published in service manuals or provided with your alignment equipment. When replacing tires, check for wheel, side flange, and split ring damage, and replace damaged parts as necessary. Rust and corrosion on steel rims can be cleaned using a wire wheel or abrasive pad, and then primed and painted. Never use abrasive cleaners on aluminum rims, as they can lead to stress cracks and wheel fatigue. Always follow the procedures to dismount tires step by step. Always use a tire cage to dismount tires. Regardless of how well you think you know the proper dismount sequence, always refer to the procedure before attempting to dismount a tire. When replacing tires, never mix radial and bias ply tires on the same axle. Mismatched tire sizes will lead to excessive tire wear. Measure the tire sizes with a tape measure or caliper before installing. When installing dual wheel assemblies on the drive axle, lightly lubricate the spindles and use a thread protector. Wheel bearing diagnosis is necessary when investigating the cause of vibration or noise problems. Loose wheel bearings will cause loose steering, tire wander, shimmy, and vibrations. Loose bearings should be removed for inspection, cleaned, and then reinstalled. Wheel bearings should be adjusted to less than .005 inches end play, no preload. If there are signs of wear on the bearings or races, consult a wear diagnosis chart to determine the root cause of the problem. Correct the cause, then replace the bearing and races. The truck frame is subjected to great stress from loads. The most common types of frame damage are sags, twists, and buckles. Frame cracks or sagging is usually caused by overloading, uneven weight distribution, or a frame weakened by incorrect modification by body manufacturers, or collision. Other frame conditions are usually caused by collision or by improperly towing the vehicle, or towing something improperly with the vehicle. Diagnosing frame misalignment is usually done with a plumb bob to mark location points on the floor. With the truck removed, the distance between the location marks on the floor can be measured easily and compared to the vehicle specifications. If the frame requires repair, the frame can be straightened or reinforced with fish plates, C or L channels. Straightening requires the use of a frame press. Frame reinforcements can go inside the frame rails on both sides of the frame rail, or be an L or a J channel reinforcement, or a fish plate reinforcement. The type of reinforcement depends on where the stress of the load that caused the failure is placed. Fish plate reinforcements can be bolted to the outside of the frame with SAE grade 8 bolts and nuts placed in a rectangular pattern to strengthen the frame. The reinforcement may extend below the frame. Bolts are the preferred fasteners for frame reinforcements. For frame repair, welding is usually only done to repair frame cracks. Common welding techniques are MIG, TIG, and arc welding. If the repairs are done using an arc welder, make sure to disconnect all batteries prior to welding, or onboard computers may be damaged from induced voltage spikes. In this video, we have looked at the 5 task areas of the ASE Suspension and Steering Test T5. We've looked at some of the diagnostic procedures you can use to get to the root cause of problems, and we looked at some repair procedures to ensure the repair is both safe and lasting. If there are any topics we've looked at or any areas of the suspension and steering task lists that you are unsure about, pick up one of the excellent textbooks or test preparation guides and make sure to brush up on those areas before taking the ASE test. Thanks for watching.